Hey everyone, welcome back to the channel. In this video, we are going to explore one of the most powerful and useful feature of Terraform meta-arguments for each. If you have been manually defining multiple resources in Terraform, then for each meta-argument is going to make your life much easier. So without further ado, let's get started. First off, let's just understand what is Terraform for each meta-argument. For each is a meta argument that allows you to create multiple resources dynamically based on a set or a map. For example, you're asked to create multiple Google Compute instances. If you don't know how to use for each meta argument, then you are going to write multiple resource blocks in your Terraform script. Although you would be able to create GCP instances, but the Terraform configuration is not standard, flexible, and dry. Every time you have to add a resource block, and at the end, there would be a really huge Terraform script. On the other hand, if you would use Terraform for each meta argument, then with a single resource block, you can create as many GCP instances as you can. This is the power of for each meta argument. This makes your Terraform code flexible and dry. You might be wondering what is the difference between for each and count. Count is used when you have a simple list and want to create a fixed number of resources, whereas for each is best when dealing with a set or map, where each item has a unique key. We can see the major differences between for each and count with this table. Count uses list, whereas for each uses maps. And there is one of the major reasons why for each is preferred, as for each removes Terraform resources safely. Let's just see this with an example why for each is better. Please have a look on this Terraform configuration carefully. If you would remove VM from the list, Terraform will recreate all the VMs due to index shifting. For each ensures that each instance has uniquely identified by its key, preventing unnecessary recreations. This makes for each is preferred choice for managing named resources like compute instances. Let me show you how Terraform for each meta argument works in a quick hands-on demonstration. In my Visual Code Editor, I have already defined some Terraform configurations. So under providers.tf, I have defined Google provider, and in this provider block, I have already configured credentials, project, and reason. The project and reason, I have defined the values under variables.tf, and we are using this GCP project and US Central 1 reason. To authenticate on Google Cloud, we are going to use Google Service Account. I have already created one Google Service account and downloaded the key here. Under backends, I have defined Terraform Remote Backend as Google Storage Bucket. So this is the bucket we are going to use to store the Terraform state. So if I quickly jump on Google Console and show you all the resources we are going to use in this demonstration. This is my Google Cloud Console, and under I am under service account, I have already created this service account and downloaded the key that we will use to authenticate on Google Cloud. This is the GCP project I have defined under variables.tf, and under IAM, I have assigned these permissions on my Google service account. These are very broad level permissions, but you should assign only the required permission on your Google Cloud service account. Under storage, under buckets, you can see this is my bucket, and this bucket we will use to store Terraform state. So in this demonstration, we are going to create Google Compute instances. So let me quickly show you if we have any VM instance running under Google Compute console. So you can see there is no instance running right now. Let me jump on my Visual Code Editor, and under main.tf, this is the configuration we are going to use and how for each meta argument is being used. Let me quickly explain to you. So in this example, we are going to create 3 Google Compute instances. There is only single resource block we are going to use to create 3 Google Compute instances. So under variables, you can see variable instances. We have defined the name of the instance VM1 and the machine type of the instance E2-medium, VM2, E2 standard 2, VM3, and one standard one. We are going to use for each meta argument for this resource block. Under name, we are going to use the key, and under machine type, we are going to use the value. Under boot disk, we are going to use the same boot disk Debian 12. Under tag, we are also using the key. So for first instance tag would be web and VM1. For second instance, the tag would be web VM2. For third instance, it is web and VM3. Let me just switch to our Terraform directory. Let me just run Terraform init command to initialize the Terraform working directory. The working directory has been initialized. Let me run the Terraform plan. All right, so you can see there are three to add. Like this Terraform resource block is creating three compute instances. We scroll up and this is the instance VM1. It's getting created with E2 medium machine type. This is VM2, machine type E2 standard 2. This is VM3 and machine type is N1 standard 1. So let me just quickly apply this with Terraform apply command. Let me just maximize it so it will be readable to you guys. Let me just run Terraform apply. All right, you can see the same configuration that was there in the plan. Let me just click yes. Now our Google Compute instance are started creating. Let me just quickly jump on Google console, refresh it. So you can see in here are all three instances are under creation. So it will take some moment. All right, so all our three instances has been created, and if I switch to my Google Compute instance, click refresh. So all three VM instances are created now with a different name like VM1, VM2 and VM3, and these are in US Central 1A zone. This is the location of the instance. This is the machine type E2 medium. Let me just clean up this lab to avoid the unwanted billing. Let me run Terraform destroy to destroy all three instances. All right, so you can see in the plan all three instances will get destroyed after clicking yes. These are under destruction, and if I quickly show you the Google console, these are under deletion. It takes some time, so in the meantime I'm just pausing this video and I'll come back. The instances have been destroyed, and let's just see on Google console. So instances are gone. This is how you can utilize Terraform for each meta argument to make your code flexible and dynamic. You can find this Terraform script on my GitHub. I'll add the link on this video description. Thanks for watching. If you found this video helpful, please hit the like button, subscribe to the channel and press the notification bell so you never miss an update. If you have any doubt, please drop them in the comment section. I'll be happy to assist. See you in the next video.